The HSA-Q1 handheld RF spectrum analyzer is a high specification unit designed for countermeasures use. It features a frequency range from 1 MHz to 13.44 GHz with a sweep time of just half a second over the full frequency range, faster over shorter spans. It has a spectrogram waterfall function for detailed signal analysis and a tune and listen demodulation function with AM, wide FM and narrow FM. Sweeps can be stored to USB stick with time and date stamp, and the background memory function can be used to compare previous sweeps. The unit has very high sensitivity, minus 80 dBm in sweep mode and minus 100 dBm in direct tune mode. It features a 6-inch TFT display screen which is outdoor readable. Audio can be heard through the internal speaker or through earphones. It's supplied with 2 antennae, a multi-element customer antenna and a telescopic antenna for low frequencies. The internal lithium polymer battery pack has 4 hours battery life. The main unit weighs just 1.3 kilograms and is supplied in a machined aluminium enclosure for ultimate durability. The whole package is supplied in a compact military standard carry case weighing less than 3 kilograms for true portability. Inside the package we have the main HSA-Q1 spectrum analyzer unit. We have a 23 centimeter concentric antenna for main use, a telescopic antenna that extends to 90 centimeters for low frequency use. We have an international charger with adapters for the United Kingdom, Australia, Europe and United States, a pair of earphones for audio demodulation, the user manual, and the whole package is supplied in a military standard protective carry case. The unit weighs just 1.3 kilograms and is designed for handheld use and features a retractable stand if required for desktop use. The antenna simply screws into the TNC antenna socket. On the side of the unit we have the 5-volt micro USB charge socket with red and green charge LEDs. We have the earphone jack for audio demodulation and we have the USB stick socket for storing sweeps. So here we have the main screen. On the bottom left of the screen we have the start frequency of the sweep, which is 0 MHz. On the bottom right of the screen we have the end frequency, which is 13,440 MHz or 13.4 GHz. The sweep count is shown at the top left of the screen. We're approaching nearly 2,000 sweeps since power on. In the centre of the screen we have the time and date. On the top right of the screen we have the battery level indicator and the waterfall spectrogram colour chart, which I will explain further later. The centre of the screen is divided up into blue divisions. Each division is identified here on the top right hand side. We're currently showing 1000 MHz for each division. Live detected signals are shown in white. Historic detected signals are shown in red. The yellow cursor line is a line that can be moved across the screen using the left and right arrow keys to home in on any specific detected signal to identify its frequency or demodulate it for further analysis. There are 5 sensitivity settings. We're currently set on sensitivity 5, which is maximum. This is picking up the whole RF environment in the near vicinity. To reduce the sensitivity or increase the sensitivity, press the sensitivity button to scroll through. We're now on 1 minimum, 2, 3, 4, and back to 5 maximum. Depending on the frequency span selected, the scan speed can be increased. This is especially useful for analysis of fast pulsing digital signals, such as those in Wi-Fi, cellular and GPS devices. The scan speed is shown at the top right of the screen. We're currently in fastest mode. By pressing the scan speed button, you can scroll through normal, fast and fastest. The HSA-Q1 features a full colour graphical waterfall function to enable the user to further analyse signals over time. This is especially useful for analysing modern digital pulse signals or frequency hopping signals, such as those from cellular, Wi-Fi, burst and GPS-based devices. So here we can see the screen. We have the top half of the screen as a compressed normal sweep and the bottom half of the screen in waterfall mode. And you can see the screen is scrolling down from top to bottom. The colours are detected signals and they relate in signal strength to the spectrogram on the top right of the screen, ranging from blue for weak signals all the way through to red for the strongest signals. This is a detected scan of 2.4 gigahertz Wi-Fi in a residential area. So here we have a detected signal on the screen. It's quite a strong signal. Our sensitivity is very low on number 2, so that's a strong signal in the area. If we move the cursor over to that signal and get it in line with it as best we can, until the cursor sits in parallel with it, then we zoom in. We've now zoomed in to an 800 megahertz span. Zoom in again, and again, and again. Move the cursor back over to the center. Carry on zooming in, and just trim the cursor to it's over the center of the signal. And now we have the cursor in perfect sync with the detected signal. Now, to find out what that signal is, we can now enter tune and listen mode by pressing the tune and listen demodulation button. So we're now in tune and listen mode, and you can see it says demodulating wide FM. We have the signal strength on the left of the screen. It's a very, very strong signal. And we have the demodulation frequency set at 399.453 megahertz. And the signal strength in dBm is minus 32 dBm. We have the volume level here, and if we use the up and down arrows to adjust the volume, we can turn the volume up and listen to the signal. Now, just next to me, I have a listening transmitter, which I'm now speaking into, 1, 2, 3, 4, and hopefully you can hear the audio from that transmitter. If I remove the battery, you'll see that the signal's gone, and we're just getting white noise. If I put the battery back in, we're now detecting the signal again. Here we have an example of persistence mode. We're set between 2380 and 2480 megahertz, which is the Wi-Fi area. So we're currently picking up a Wi-Fi router, and there also is another signal present as well. Now, the longer the signal is present, i.e. the more persistent it is, the colour will change from blue through the colour spectrum to red for the longest, most persistent signals. As you can see, over time, we're getting this one signal in the middle, which has already turned red, whereas the other signals, which are the Wi-Fi router in the area, have stayed on much cooler colours. This is actually from a detected signal from a wireless video camera on 2.4 gigahertz, which is hidden within the Wi-Fi band. The HSA-Q1 can perform a background scan where it will learn and store the current RF environment in internal memory. This can also be stored to a USB stick and recorded at any time for future comparison. Press the background button to enter background mode, and you'll see a list of background settings. To start a new background scan, scroll down and select Start New Background Scan. The background scan will usually take around 2 minutes to complete, and once completed, you can leave the screen and go back to the background menu. To now subtract any detected signals from the previously stored background scan, go back to background mode, scroll down to subtract background from live, and you'll see all those signals have now disappeared. Only new signals since the background scan will now be shown.